All right, today, this is section 4.4 in your book. We're going to talk about linear inequalities in two variables. They're similar to regular inequalities that we graph on a number line that have one variable. We need to graph an infinite number of solutions. So the steps to doing this are you write, this should be the equation in slope-intercept form. Determine whether the line should be solid or dashed based on the inequality sign. This means if you have less than or greater than, your line is dashed. If you have less than or equal to or greater than or equal to, your line is solid. Then you graph it, and then you use a test point to determine which side of that line should be shaded. The shaded area includes all of the ordered pairs that make that inequality true. All right, here's how you do it. This one's already in slope-intercept form. So we have a less than symbol. So it's going to be a dashed line. I'm going to use black ink or purple. Let's do purple. So I'm going to graph this like I would graphing a linear equation. This kind of weird coordinate plane here. Okay, so the line's going to be dashed because it's a less than sign. Make the line dashed. Okay, so now we're going to pick a test point. Unless it's right on the line, I always pick 0, 0 because the math is super easy then. So here's my test point. I'm going to plug it into that equation. So y is 0 less than 2 times 0 minus 1. So is 0 less than negative 1? No, that's not true. So we're going to shade the side of the line without the test point. If it's not true, that means that 0, 0 isn't a solution, so you got to shade the other side. I'm going to get a highlighter here. Sometimes it's good if, let me get a better colors. Sometimes it's good if you guys can use colored pencils. We're going back to yellow. So you're going to shade the entire side without the test point because the test point is not a solution to that inequality. Okay, so you didn't need to watch me color that. Any points that are right on the line, in this case, are not solutions because this is telling me less than, up to the line. Okay, let's try another one. Okay, I need a pen. Already in slope-intercept form for us, so I'm going to start at 2, go up 1 over 3. Okay, so this one says greater than or equal to, so this is a solid line. And again, I'm going to use the test point 0, 0. When I plug in 0, I have 0 is greater than or equal to 2, which it's not. So we're going to shade the side without the test point. Okay, here's what your graph looks like when you shade it in. This time, any points that are on the line are included because of that greater than or equal to. All right, let's do this one. I have y is greater than or equal to negative 3x. Let me get my pen back. I'm going to graph that. My y-intercept is 0. And because it's greater than, this is a dashed line. And we can't use 0, 0 here because we go right through it. You can, but I don't want to. So I'm going to use 1, 1. Still pretty easy math. So I have y is greater than, or 1 is greater than negative 3 times 1. 1 is greater than -3, and it is. So this time we're going to color in the side with the test point. That's what it should look like when you shade it, because here's the test point right there. All right, next one. This one we have to put into slope-intercept form before we graph it. So I'm going to rearrange it. Oops, there's a y here. So I'm going to subtract 2x from either side. So I have y is less than or equal to -2x plus 3. So I'm going to start at 3. Okay, so it's less than or equal to, so it's going to be a solid line here. Well, not too straight, but did the best I could. I'm going to go back to my test point of 0, 0. Doesn't matter where you plug it in. I go back to the original. So I have 2 times 0 plus 0 is less than or equal to 3. So I have 0 is less than or equal to 3, which it is. So I'm going to color the side with the test point. So that's what it would look like. And remember, this is or equal to, so points on the line would be included in ordered pairs that would make this true. All right, I think we have one more. I have to rearrange again. Oh, this is a weird one. Okay, so I'm going to add 12 to each side here. So I have 2y is greater than 16, and I am going to divide by 2. So if you remember how to graph y equals something, you're going to go up on the y and you're going to graph this. So it'll be a dashed line on the 8 here, like that. So if I pick my test point 0, 0, and plug it in, is 0 greater than 8? No, that's not true. So we're not going to color the side with the test point. So we're only going to color that tippy top up there. Right up here. That's where we would shade. And you know, that doesn't, it doesn't mean only a few numbers are a solution, because you know this goes infinitely in both directions, but this is just all that's showing. So that's our solution to that one. And that's it.